Pre-Cal students, welcome to the homework help video, page 571, 1 through 15 odd, and 33 through 41 odd, the A's only. Let's go ahead and get started with numbers 1 and 3. The directions say to find the missing side using Pythagorean's theorem, and then to find the 6 trig functions. So let's go ahead and get started using Pythagorean's theorem. You will see that this will be a 10 right here. I'll show you quickly. Leg squared plus leg squared equals hypotenuse squared. This would be 36 plus 64, and 36 plus 64 is 100. 100 equals hypotenuse squared. Take the square root of both sides, and 10 equals h. Okay, so there's the hypotenuse, and now let's go ahead and find the sine, cosine, tangent, cosecant, secant, and cotangent of theta. The sine of theta equals opposite over hypotenuse. That would be 6 over 10, which is 3/5. The cosine of theta would be adjacent over hypotenuse, 8 over 10, which reduces to 4/5. I guess I should stop and say this. If we're dealing with this angle here, let's go ahead and label our 3 sides. Go straight across. This is our opposite side. Here's the right angle. Go straight across. This is our hypotenuse side. And the third side left over has to be your adjacent side. Okay? Let's go ahead and find the tangent of theta. The tangent of theta is opposite over adjacent, so that would be 6 over 8, which reduces to 3/4. Let's try the cosecant. The cosecant of theta, well, remember, we can do this one of 2 ways. We can say the cosecant is hypotenuse over opposite, which would be 10 over 6, and reduce that, we get 5/3. Or you can remember that cosecant is always the reciprocal of sine. So if the sine of theta is 3/5, then the cosecant of theta is 5/3. That's a fast way to do it. The secant of theta would be the reciprocal of the cosine of theta, and the cosine of theta is 4/5, so the secant of theta would be 5/4. And then the cotangent of theta is the reciprocal of tangent, and so the tangent of theta was 3/4, so the reciprocal would be 4/3. Okay, let me check these in the back of the book real quick to make sure I've not made a mistake anywhere. Yep, we're good. Let's go ahead and move on to number 3. Okay, let's go ahead and use Pythagorean's theorem to find this missing leg. We are missing a leg, by the way, so we have 9 squared plus leg squared equals hypotenuse squared. And then we would have 81 plus L squared equals 41 squared would be 1,681. And then we'll subtract 81 from both sides, and we're left with 1,600. And the square root of 1,600 is going to be 40. So this missing leg right here would be 40. So here we go, moving on very quickly. Here's theta, so go straight across. 9 would be your opposite side. Here's your right angle, go straight across. 41 would be your hypotenuse, and the last side here would be your adjacent side. Okay, so sine of theta would be opposite over hypotenuse, 9 over 41. The cosine of theta would be adjacent over hypotenuse, so 40 over 41. And the tangent of theta would be opposite over adjacent, 9 over 40. And then, of course, the cosecant is the reciprocal of sine, and so the cosecant of theta would be 41 over 9. The secant of theta would be the reciprocal of cosine, and so secant of theta would be 41 over 40. And then cotangent is the reciprocal of tangent, and so the cotangent of theta would be 40 over 9. Okay, hopefully that makes sense. Let me get a drink here real quick, and we'll continue on. Now, the directions say to, if I remember correctly, they want us to find the 6 trig values of theta for each of the 2 triangles and explain why the functions are the same. Now, that's a lot of work. I'm not sure if we'll do that for every single triangle, but let's first of all do this. Let's find the missing side here and the missing side here. So Here we're missing a leg, so we have 1 squared plus leg squared equals hypotenuse squared, which would be 1 plus L squared equals 9. Bring the 1 over and make it a -1, and we're left with L squared equals 8. Take the square root of that, and L equals the square root of 8. And you should remember how to break that down from earlier math classes. 8 is the same thing as 4 times 2. Cross off the 4, put a 2 on the outside, and so we're left with 2 square root of 2. Okay? And then let's quickly find the missing leg for this triangle here. We have a leg squared plus a leg squared equals my hypotenuse squared. So 4 plus leg squared equals 36. Subtract 4 from both sides. L squared equals 32. And then take the square root of both sides. Leg equals square root of 32. And of course that can be broken down into 16 times 2. And we do know the square root of 16, so cross off the 16, put a 4 on the outside, and your leg is 4 square root of 2. Now, first of all, let me get a drink here real quick. First of all, let's deal with why the two triangles have the exact same trig function values, okay? Because the two triangles are similar. I mean, that's obvious, okay? My pen's not, well, I'll just abbreviate it. There we go. Look, we have 1 increases to 2, so you took 1 times 2, and it gave you a 2. The 3 increased to a 6. Well, that's 3 times 2. 2 square root of 2 increased to 4 square root of 2. You multiplied each one of these sides by 2. And so this triangle here increased by the same ratio or the same factor of 2. So that is why the trig functions for one triangle will be the exact same for all the triangles. Let me show you what I mean real quick. Let's take the sine of this top angle here, opposite over hypotenuse. The sine of theta equals 1/3. Now let's find the sine of theta for this triangle down here, and we should get 1/3. Opposite is 2, hypotenuse is 6, so the sine of theta is 2/6, which reduces to 1/3. Okay, let's find the cosine of theta real quick. I'm not going to do all 6 of these, but the cosine of theta for the top triangle would be adjacent over hypotenuse. So 2 square root of 2 over 3. Now let's find the cosine of theta, and let's use this triangle down here, adjacent over hypotenuse. So 4 square root of 2 over 6. Now if you remember from algebra class how to reduce a fraction that has a radical, you do not reduce outside numbers with outside numbers. This is an inside number, it's under your radical. This is an outside number, and this is an outside number. You do not reduce inside numbers with an outside number. For example, you don't say 2 goes into 2 once and 2 goes into 6 3 times. You can't do that, okay? You have to reduce outside numbers with outside numbers and inside numbers with inside numbers. So the 4 and the 6 are both outside numbers. They can be reduced. 2 goes into 4 2 times. 2 goes into 6 3 times. So you're left over with 2 square root of 2 over 3, which is the exact same answer we have up here. So on your homework, you probably have to go through and do these. I'm not going to take time on the homework help video and do all of these for you. But I will do one more because I want you to realize sometimes you're going to have a radical in the denominator, and you really need to remember to reduce or to rationalize a radical that's in the bottom of your fraction. So let's do tangent real quick. Tangent of theta equals opposite over adjacent, 1 over 2 square root of 2. Now this is not an acceptable answer because we have a square root in the denominator, and the square root that we want to get rid of is square root of 2. So whatever you're trying to get rid of, you multiply the top and the bottom by that radical, okay? And this is called rationalizing a denominator. You're getting rid of the square root in the denominator. So 1 times square root of 2 is square root of 2. And I'm going to erase this over here to get a little bit more room to work with. And then 2 square root of 2 times square root of 2. Pretend there's a 1 right here. You would have 2 times 1, which is 2. and then 2 times 2, which is 4. So you have 2 square root of 4. Well, we know the square root of 4 is 2, so instead of writing 2 times the square root of 4, I really have 2 times 2, because the square root of 4 is 2. So I end up with the square root of 2 over 4, and that's the correct answer. And by the way, if I found the tangent of theta using this bottom triangle here, I would get the exact same answer. I'll show you very quickly. Opposite over adjacent. There we go. We do not want the square root of 2 in the denominator, so we multiply the top and the bottom by the square root of 2. 2 times the square root of 2 is 2 square root of 2. And remember, there's a 1 right here, so 4 times 1 is 4, and square root of 2 times square root of 2 is square root of 4. Now, I know the square root of 4 is 2, so instead of having 4 times the square root of 4, I'm really going to have 4 times 2. So I end up with 2 square root of 2 over 8, and then notice your outside numbers can be reduced by 2, and so you end up with square root of 2 over 4, which is the exact same answer we had up here. So it did not matter which which triangle we used, because the two triangles are similar. Because of that, we know that the trig values will be the same for either triangle. All right, let's take a look at number 7. Very quickly, let's find the missing side here. We're missing a leg right here, so I have a leg squared plus a leg squared equals the hypotenuse squared. If you square the 1, you get a 1, and if you square 1.25, you will get 1.5625, and then we subtract 1 from both sides, so we're left with the leg squared equals 0.5625, and let's take the square root of that very quickly, and we will get 0.75. Okay, so this leg right here is 0.75 exactly. All right, and now let's find the missing side in the other triangle here. One leg is 4, the other leg is what we're looking for, so leg squared. And the other side would be the hypotenuse, which is 5 squared. So we have 16 plus leg squared equals 25. Bring the 16 over and make it a negative 16. We get 9. Take the square root of both sides, and L equals 3. So there we go. Now, if you'll compare these two triangles, notice we took all of these sides times 4. If you'll just watch, I'll show you in a second. Okay. Now, if you take 1 times 4, you get 4. If you take 0.75 times 4, you will get 3. And if you take 1.25 times 4, you will get 5. Okay, so these two triangles are similar, and of course the symbol for that is this, similar. So the two triangles are similar, so it really doesn't matter which triangle you use to find the sine, cosine, and tangent. To me, it would be common sense to use the bottom triangle here, because you have nice, easy whole numbers, 3, 4, 5, and up here you have these decimals, but that's up to you. So very quickly, sine of theta would be opposite over hypotenuse, 3/5. The cosine of theta would be adjacent over hypotenuse, 4/5. The tangent of theta would be opposite over adjacent, 3/4. The cosecant of theta would be the reciprocal of sine, so 5/3. The secant of theta would be the reciprocal of cosine, which would be 5/4. And then cotangent would be the reciprocal of tangent, which would be 4/3. Let me check the answer key real quick to make sure I'm not making a little mistake somewhere, but this does look accurate, and yes, it is. Okay. All right, let's continue on to numbers 9, 11, 13, and 15. We're going to set up a triangle and find the missing side, and then find the other 5 trig functions. So we're going to draw a quick right triangle. We do not care if it's drawn to scale. That's not a big deal. We're going to put theta wherever you want to put it. You can put theta up here, or you're welcome to put theta down here. That's totally up to you. Okay, I'm going to put it up here. And so what I know is this. I know that the sine of theta is 3/4, and the formula for sine is opposite over hypotenuse. So I know the opposite side of theta is 3 and the hypotenuse is 4. Okay? So with that in mind, I can very quickly find this side over here using Pythagorean's theorem. So here we go very quickly. Leg squared plus leg squared equals hypotenuse squared. 9 plus leg squared equals 16. Bring the 9 over and make it negative. We get 7. And so the leg equals the square root of 7. And now that quickly, we are ready to go. So the cosine, the sine of theta is 3/4. The cosine of theta would be adjacent over hypotenuse, square root of 7 over 4. The tangent of theta would be 3 over square root of 7. And if you rationalize the denominator, which you're supposed to do, you will get 3 square root of 7 over 7. Okay? And please don't try to reduce this 7 here and this 7 here. One is an inside number and one is an outside number. Okay? Moving on, the cosecant would be the reciprocal of sine, so the cosecant is 4/3. The secant would be the reciprocal of cosine, so 4 over square root of 7, which would then equal 4 square root of 7 over 7. And then the cotangent of theta would be the reciprocal. And don't forget, the original answer was 3 over square root of 7. So we can flip this and we will get square root of 7 over 3. Okay, moving on to number 11. Okay, secant of theta is 2, and of course 2 is really 2 over 1. Now don't forget the formula for secant. Secant is the reciprocal for cosine. Cosine is adjacent over hypotenuse, so secant here would be hypotenuse over adjacent. Okay, and let me quickly go back. I need to check my answers to make sure I'm not making a mistake anywhere, and everything so far looks good. So yes, we're good. Okay, moving on back to number 11. So here's my right triangle that I'm going to draw. It doesn't matter where you put theta. I'm going to put it down here this time just to be different. The adjacent side is 1. The hypotenuse is 2. So we're going to find this missing leg over here. So I have a leg squared plus a leg squared equals a hypotenuse squared. I'm going to go a little faster now. If you do all of your simplifying, you will be left with L squared equals 3. And so the leg equals the square root of 3. Okay, so our missing side is square root of 3. So going very quickly, sine of theta would be opposite over hypotenuse, square root of 3 over 2. The cosine of theta would be adjacent over hypotenuse, 1/2. And the tangent of theta would be opposite over adjacent, square root of 3 over 1, or just square root of 3. The cosecant of theta would be the reciprocal of sine, so 2 over square root of 3. If you rationalize that, you'll get 2 square root of 3 over 3. The secant of theta we already know is 2 over 1. And the cotangent of theta would be the reciprocal of tangent, so square root of 3 over 1. That would be 1 over square root of 3. And if you rationalize that, you'll get square root of 3 over 3. And that'll be your answer, okay? Let me check those real quick. And we're going to be moving on. Okay, let's take a look now at number 13. The tangent of theta is 3 over 1. Tangent of theta is 3 over 1. And we know the formula for tangent is opposite over adjacent. So here's my right triangle very quickly. Not exactly super straight. And let's see, one of my legs will be, we'll call theta up here. My opposite is 3, my adjacent is 1. And if you do all the math in this, if you get 1 squared plus 3 squared equals hypotenuse squared, you will end up with 10. Square root of 10 equals your hypotenuse, okay? And here we go. Sine of theta would be opposite over hypotenuse, so 3 over square root of 10. And if you rationalize that, you will get 3 square root of 10 over 10. All right. The cosine of theta would be adjacent over hypotenuse, so 1 over square root of 10. If you rationalize that, you will get square root of 10 over 10. All right, we already have tangent up here. Let's go on to the cosecant. The cosecant of theta is the reciprocal of sine, so 3 over square root of 10 would be the same thing as square root of 10 over 3. The secant of theta would be the reciprocal of cosine, so 1 over square root of 10. If you reciprocate that, you'll get square root of 10 over 1, or just square root of 10. And the cotangent of theta would be the reciprocal of tangent. Tangent is 3 over 1, so cotangent would be 1/3. Let me check these answers real quick to make sure we're not making a mistake anywhere. And we're going to move on. Okay, here we go. Okay, remember cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, and so cotangent would be adjacent over opposite. Okay, so we're going to draw our right triangle here, and this time we'll put theta down here. The opposite side is 2. The adjacent side is 3. If you solved for the hypotenuse using Pythagorean's theorem, you would get square root of 13. And here we go. The sine of theta equals opposite over hypotenuse, 2 over square root of 13, which would be 2 square root of 13 over 13. And the cosine of theta would be adjacent over hypotenuse, 3 over square root of 13, which would be 3 square root of 13 over 13. When you rationalize it, tangent of theta would be adjacent over, no, be opposite over adjacent, so 2/3. The cosecant of theta would be the reciprocal of sine, 2 over square root of 13, so we're going to flip that and get square root of 13 over 2. Let's see, and I put, this should be CSC right here, CSC, and then the secant of theta would be the reciprocal of cosine, so 3 over square root of 13, that would be square root of 13 over 3, and then the cotangent of theta would be the reciprocal of no, actually we already know cotangent, so we're good there. That's already been solved for. So let me check the answers real quick in the back here and make sure everything looks good, which it does. And we are moving on. Okay, now the rest of the problems here are calculator problems, so all that I can say to you is make sure that you're in degrees. Make sure in your mode you're in degrees. If you're not, you're going to miss all of these, so make sure you're in degrees. And here we go, sine of 10 degrees, so I type in sine of 10, I hit enter, and I'm going to change colors here so y'all can see it. I'm getting 0.1736. Okay, moving on to number 35. Sine, once again, sine of 16.35, and I'm getting for this one 0.2815. There's always going to be a little pause. I'm checking the answers to make sure that they are accurate, okay? And we are doing just the A's only on this homework assignment, just the A's only. All right, moving on to number 37. Let's see here, the secant. Now what we got to do for secant here, be careful. There is no secant button on your calculator, okay? So what you're going to use is the reciprocal of secant is cosine. So with my calculator, I'm going to type in the cosine of 42 degrees in 12 minutes. I'm going to do that right now. So cosine of 12 degrees, actually 42 degrees in 12 minutes, and I'm getting something like this. I'm going to read it to you. I'm getting 0.740804596.3. Now I'm going to take the reciprocal of that by taking that to the -1 power, and you should get this right here, 1.34988. So if I round it correctly, it's going to be 1.3499 for number 37, okay? All right, number 39, cotangent. So I'm going to have to take the tangent of 11 degrees, 15 minutes. So I'm going to do that very quickly. Tangent, 11 degrees, 15 minutes. And I'm getting 0.198912367.4. Now I'm going to take the reciprocal of that, and I'm going to get this right here, or take it to the -1 power, 5.02733. So 5.0273. And then number 41, cosecant, which means I'm going to have to use the reciprocal, which is sine. So the sine of 32 degrees, 40 minutes, and 3 seconds. So I'm going to hit sine, and then 40 degrees, 32 degrees. Let me fix that real quick. 32 degrees, and then 40 minutes, and then 3 seconds, and hit enter. I'm getting 0.5397629017. I'm going to raise that to the -1 power, and if I do that correctly, I should get 1.85266. So I'm going to round it to 1.8527. Okay. So that should be it for the homework help video. I hope this has been a help to you. Not too difficult stuff, just learning basically how to find the trig functions using right triangles, then also learning how to find trig function values using our calculators. Okay?